Okay, in this problem, we are going to explain Coulomb's law in vector form. Okay, so what do we mean by that? Imagine that we have a charge A, and let's say this charge is positive and it has a value QA, and then we have a charge B, and then this charge is also positive and it has a value QB. So we know these two charges are going to repel, and we want to find out how to write F, the force from A on B, the force on this guy in vector form. Okay, so that'll be something of the type Fx, some component in the x direction, times I plus Fy, some component in the j direction times j. And we know that vector is going to be a vector that points in that direction and it has some magnitude. So first let's set a coordinate system. This is our coordinate system. And then let's say this guy here, the vector from A, let's call that RA. And then we have a vector from B, and this is RB. Okay. And then what is this vector here? What is this vector that goes from A to B? Okay. Well, we know, let's call that vector R. So we know that RA, which is this vector, plus R, right? RA plus R have to be equal to RB. And this plus this is equal to this. So therefore, R, vector R, which is what we want, is RB minus RA. So now we can write, now that we know what this R is, we can write this force, and then after that we'll break it into components. So let's start writing that force. F A on B, right? That is equal to what? Is equal to K, that constant, remember? QA, QB, okay? Divided by the magnitude of this guy square, the magnitude of this vector square, times a unit vector in this direction. Okay, what that means is I need to find a unit vector that points in this direction so I can get the direction of my force, because the force is going to be, the force is applied on this line here. Okay, so I need to get this R. So let's do it over here. What is this R? Well, a unit vector is defined as the vector R divided by the magnitude of the vector. Okay, that is your unit vector. Okay, so that's all that goes in here. So now let's start doing all the algebra here. So let's start by writing RB or RA. Let's start with RA. RA is equal to XA in the I direction plus XB in the J direction. XA would be this vector here, and this vector here, right? And this other vector here is the other component. Okay, so this one here is XA, this one here is XB, and then I can write RB, and that is XB I, sorry, and this is supposed to be A plus YBJ. And I made a typo here, so let's just delete this. Okay, it's not working, so let's try it again. Okay, there, worked. So this was supposed to be, okay, so this is your vector RA, this is your vector RV. So what is then RB minus RA. Well, this is what? This is XB minus XA in the I direction plus YB minus YA in the J direction. And I can do a little more here. I can go ahead and find the magnitude of, this is R, and then the magnitude of R is equal to what? Well, by Pythagoras is equal to the square root of XB minus XA square plus YB minus YA square. So that is your vector. So, and we probably at this point have everything we need to write this force. We can just go ahead and write FA on B vector is equal to what? Well, is equal to K, right? Then there's going to be this R squared here, which gives me XB minus XA square plus YB minus YA square. Okay, these two, this square here, right? And then I'm going to have now up here QA, QB, and this is the magnitude of the force. We just need to multiply that by this unit vector, and that unit vector is what? Is this quantity here is xb minus xa in the I direction plus yb minus ya in the j direction divided by the magnitude of that, which is the square root of xb minus xa square plus yb minus ya square. Okay, so now I can go ahead and rewrite this. Can go ahead and rewrite this, and I'm going to do that. And I'm gonna rewrite all this thing here, and this is gonna be a long equation. So this here is F A on B, that is equal to K Q A Q B. Okay, and then this multiplies the whole thing here. So I have this quantity here, this times this is going to give me this number here, this xb minus xa square plus yb minus ya square to the 3/2. And this 3/2 you're going to see a lot later when we study fields. You're going to see that there are many solutions that come out with 3/2 here. So, and up here, what do we have? We have xb minus xa in the y direction plus yb minus ya in the j direction. Okay, so that's that. So that's the vector, that's the force in vector forms. This is a vector. And at this point, you might be lost because there's a lot of algebra here. So let's just apply this to a simple problem. Let's assume that we have this configuration. We have a charge here at the origin, and then we have another charge here, and this charge is at a distance a and a here, right? So what is the force on this charge? And let's say they both have charge Q. And what is the force on this one due to this one? Okay, so well, this is the equation, right? So we know that the vector for this guy is 0. This is RA here, that would be 0. So this number is 0, this number is 0, this number is 0, and this number is 0. And what is the vector for this guy? Well, RA, let's just write it down, because this would be A, this would be B. Our A would be 0I plus 0J. Our B would be what? Our B would be AI plus AJ. And therefore, RB minus RA, that is just simply AY plus AJ. And then I can write this F A on B vector that is equal to K QA QB. Okay, so then I get AI plus AJ, that is putting these numbers here, and I get that this is what? This is the square, sorry, this is a bracket here of what? A square plus A square to the 3 half. And then we can rewrite this as K QA QB, and then down here I'm going to have square root of 2A square. Sorry, not the square root. Sorry about that. Let's just delete this guy here. And doesn't work. Alright, so then this is what this is 2A square to the 3 half, and then I get AI plus AJ. And then I can even simplify this further. We can simplify this further. This square is going to cancel with this. And I can do some extra simplification. So this is K, QA, QB. Then you're going to get the square root of the 2 to the 3 half. Then you get A cube and then AI plus AJ. And you can even simplify this further, but the point that I wanted to make is that if you think about every chart having a vector RA and a vector RB, and then finding this vector here, and then writing this equation, and then if you know how to write this unit vector and this magnitude here, then you should be okay to understand this. Right, thank you very much.